Hello again, this is Carsten OZ9 Alpha Alpha Radio with a short video on some of the stuff that has been added to the REPAM and the dual RF combination. This time it's primarily software. The PA monitor application, PC application for Windows has been extended with a few things. Most important is the ability to make voice messages when an alarm should occur in your PA. It could be high SWR, high temperature, and so on. And just to show you how to set that up, I'm going to make a small demonstration here. First on the screen we have the PA monitor application, which is of course a free application, and you can even get it in a full project with source code and everything. The program is developed in C# in Microsoft Visual Studio 2022, and you can get the source for the project, and you can change it and tweak it so it fits better with the purpose you want it for. The other application is the REPAM monitor, which is used for configuring and setting up the REPAM device, calibrating the dual RF head if connected, and so on. First off, we are gonna power on the power amplifier. Again, it's a 500 watt, 70 centimeter LDMOS amplifier for EME that I'm building. It's controlled by a small board, overcurrent board with switching on and off, which is also available on my website. You can find more information there. In the future, I will make a separate page for the complete PA project, but I haven't gotten to that point yet because of all this other stuff. But let's start by powering on the PA. You see the VDD on the LDMOS went up to 52 volts, and we are still in receive. So I will go and transmit, activating the PTT, and you see that we have a small power of 40 and so on. We go up to around 500 watts here, and everything is working sweet and nice. So remove PTT again, and you can see the fans started moving. Let's say we want we have a high SWR alarm, and in the PA monitor on the alarm tab you can see the text for the various alarms. We can have up to 12 alarms. Each trigger on the device can trigger an alarm. They can also control the relay outputs and so on, but they can each have an alarm. And I have defined 4 alarms, and for each alarm I have selected a message file, a WOW file. So this is set up once and for all. Then if we look in the REPAM monitor, in the settings for the connected REPAM device, you see the 4 first triggers. SWR above 2 will trigger the high SWR. Trigger 2, if temperature sensor T2 exceeds 60 degrees, we will get the high temp alarm. Input trigger 3, if analog input 3, which is the input that measures the current through the LDMOS, if that one exceeds 20,000 milliamps or 20 amps, we will get the high current alarm over here. And the 4th is input trigger 4. If the 4 watt power gets above 550 watts, we will also trigger an alarm. And this is the high power. So let's to get some action here. Let's one more thing. You see the SWR and the overcurrent. They are controlling digital output 2. That's the relay output 2. they will give a pulse of 2 seconds in both cases if they trigger. A pulse on DO2 will actually shut off the power to the amplifier. So if either the SWR exceeds 2.0 or the LDMOS current exceeds 20 amps, the power to the PA is going to be cut off, and the PA will stop transmitting immediately. The reaction time for this to happen has to be pretty quick in order to hopefully avoid burned LDMOS and so on. And when monitoring the SWR, the moment from when the SWR condition, the high condition is seen, and until the relay contacts of a relay it's controlling has closed, effectively is closed at 0 ohms. It takes 2.3 milliseconds for the SWR. The SWR and forward and reflected power, which are calculated based on inputs from the dual RF head, the reaction time is around 2.3 milliseconds. All other inputs, analog inputs that has to trigger a relay is around 3.5 milliseconds. They're a little bit slower because the SWR and so on are prioritized and they need to react very quickly. So 2.3 and 3.5 milliseconds is the reaction time. So to demonstrate, let's say that instead of 2.0, we want 1.1 in SWR. If you noticed when I tested the PA just before, the SWR on my dummy load is actually 1.1 something. So I set the limit to 1.1, okay? And we write that to the REPAM device. This has now been transferred to the REPAM device. And let's, I will now go and transmit. You see the power is still on to the amplifier. I go and I hit the PTT.
Alarm. High SWR.
And you heard, I hope you heard in the microphone that it said alarm high SWR. And the PA, as you can see, was immediately switched off. The high SWR was, for a very, very short moment, it was red. An alarm indicator is red while the alarm is active. And if the alarm goes away by itself, which it's of course did in this case because the power was removed to the PA, so the SWR fault condition was removed, they will turn yellow to signal that this alarm has been activated. And you can return it to green again by clicking on it with the mouse, and then the alarm is gone. So this was just a quick demonstration. We can, oh sorry, let's return it to 2.0 again, SWR, and we write it, and we turn on the power once again, and I go and push the PTT, and you see now we just transmit like we normally do. So this was just a short, I hope a short demonstration of how to make alarms. And as I said, you can make an alarm for each of the triggers. So you could make other alarms. You don't have to put voice messages. If there is a voice message, it will be played once the alarm occurs. And when you add more alarms, you can see the user interface adapts. This is an alarm that has been triggered before. And as I said, you can have up to 12, and they will be dynamically shown. Let's remove those again. So this is it. I hope you enjoyed it, and as I said before, go to my website www.moonbounce.dk, where you can find more information download all the user manuals, a lot of other projects you can have a look at. Thanks for now.